Tidal energy. What is tidal energy? What are the advantages and disadvantages of tidal energy? How is tidal energy used in the modern world? What is the comparison between tidal energy and other forms of energy? What are the practical uses of tidal energy? How has this form of energy impacted the world and how can it be better managed? This video will aim to discuss all of these and more, so sit back, relax, and enjoy this full project which I passionately created. Section 1. Introduction. Tidal energy is a renewable energy that is both predictable and reliable as tides are generated through the gravitational coalesce of the Sun, Moon, and Earth. The earliest work used to describe tidal energy was put forward by none other than Sir Isaac Newton in his equilibrium theory of the tides. His main assumption is that Earth is uniformly and completely covered in water all around. By just considering the influence of the Moon, Sir Newton proposed that the Earth and Moon rotate around a common center of mass and that centrifugal forces are created to balance the gravitational attraction of these two bodies. On the surface of the Earth, the centrifugal forces essentially push the water further away from the Moon. The gravitational force of the Moon on the surface of the water closest to it is enough to overpower the centrifugal forces and hence push water towards the Moon. The large gravitational force covering the diameter of the Earth is not enough to counter the centrifugal forces at the far side of the latter. Henceforth, you end up with two tidal bulges. In contrast to the theory of Sir Newton, the Earth is not a landless body that is completely filled with water. The effect of land masses and Coriolis force, which is an apparent force that causes a deflection in the path of moving objects such as winds and ocean currents due to the Earth's rotation, can generate extremely high tides which are about 14 meters high in length, such as at Pensin Bay in the Sea of Okhotsk. The energy from tides is manifested in both kinetic and potential energy fluxes generated by the Earth, Sun, Moon system. It is estimated that the total amount of energy that is squandered through drag and friction is equivalent to 3,000 gigawatts in terms of thermal energy worldwide. How much of this energy that is to be used in the future, however, is a matter to debate. Section 2. The practices and developments of tidal energy. As the ocean covers about 70% of the surface of the Earth, it has a very significant role in providing clean energy through tidal and wave energy. However, I'll be discussing the former in this section. There are two ways in which tidal energy is to be harnessed. One is to use cyclic rise and fall in tides using barrage, known as tidal barrage method. The other method is to use tidal currents due to movement of seawater, which is similar to wind power. This is well known as marine current method. Typically, countries with longer coastlines have much higher potential than ones with smaller coastlines to harness tidal energy. One such example is India, which has a coastline that is about 7,500 kilometers long, covering the three sides of it. There are also a variety of devices that may be used to harness the power of tidal energy. However, I will only be looking over a few of them due to time constraints. One example is the Venturi type device. This device uses a shroud which increases the flow velocity through the turbine and itself. Hence, for a given power output, only a smaller diameter of the turbine is required. It can be placed both horizontally and vertically. A second example is the oscillating hydrophores. This device consists of airplane-shaped wings called hydrophores, placed at the item of a swinging arm. As the tidal stream moves on either side of the blade, the hydrophore moves up and down, generating lift that causes the lever to rise. These oscillating movements cause water in a hydraulic system to generate power. Next is the Archimedes tidal screw. It is a helical corkscrew-shaped device that consists of a helical surface that surrounds a central cylindrical shaft. It extracts power from the tidal stream when the water moves up. The potential for tidal current is located in areas with high tidal range. However, increased potential has been observed where the flow of water is obstructed. Section 3. Barriers facing tidal energy. In this section, I'll be discussing the current issues hindering the progress of tidal energy. Alright, ready dear viewer? Then allow me to guide you through this section. The first problem would be that tidal energy often faces financing and marketing complications. Globally, the majority of tidal projects are funded by government agencies or by professional technology developers. At the present, multiple countries such as Canada, South Korea, the United Kingdom have the framework and policies to facilitate the research and the demonstration of the tidal power technology. However, necessary framework requirements have not yet evolved to sustain tidal energy projects. Due to the fact that tidal energy is quite expensive, there is a need to develop new financial mechanisms, particularly for harnessing tidal streams. Also, it requires a very serious market pull and support mechanisms. In this aspect, several policy decisions have to be made to attract investors, include large capital grants, tax exemptions, soft loans, project equity loans, and more. Now with practical experience and performance data, the industry will be able to understand the real situations and issues and will be in a position to reduce risk and cost. These measures will stimulate the confidence of investors. Next would be environmental issues. The tidal energy projects may have a variety of effects on the environment as a whole. It may impact existing ecosystems and economic activities such as fishing within the area. Hence, it is necessary to monitor the power plant project right from the stages of installation of pilot projects so that the impact on marine life, including fish, could be analyzed in a better way. Next is technology development. At present, various technologies for harnessing tidal energy already exist, but great challenges arise due to lack of sufficient experience on materials to be used, the performance facing the structures in a harsh and hostile sea environment, the lifespan, operation, and maintenance of technologies and power plants. Hence, in order to overcome this barrier, very effective, collaborative, and focused efforts are required among the participating research institutions, professional developers, and concerned government agencies and policy makers. Section 4. Tidal energy versus other forms of energy. The first comparison I will be making is with tidal energy and solar energy. While both are renewable energy sources, differences exist in their electricity generation potential. Peak solar energy efficiency ranges between 15 to 23% at the present, but tidal turbines can achieve electricity capacity factors over 40% by harnessing dense, predictable ocean currents. However, only 30% to 60% of tides at any given location can be converted into electricity. In terms of costs, tidal power is currently more expensive than solar energy. Upfront capital costs around $0.40 per kilowatt hour, exceeding solar energy's $0.045 per kilowatt hour. But maintenance costs for tidal energy are overall lower without underwater marine operations. Tidal power remains less commercially mature than solar, which has outpaced projections in cost declines. Regarding power predictability, tidal energy offers more consistent and forecastable output compared to intermittent solar output affected by weather. Next is between wind energy and tidal energy. Tidal energy is relatively more prosperous than wind energy at low speeds. Water has 1,000 times higher density than air, and tidal turbines can generate electricity at speeds as low as 1 meter per second or 2.2 miles per hour. In contrast, most wind turbines begin generating electricity at 3 meters per second to 4 meters per second or 7 miles per hour to 9 miles per hour. Tidal power is also more predictable and consistent than wind or solar energy, both of which are intermittent and less predictable. Section 5. Conclusion. Recently, development and infrastructure of tidal power technologies have made quite significant progress. Initially, the cost of tidal energy is very high, but with achievements in research and development, it will drastically reduce. In order to overcome the aforementioned barriers to tidal energy, very effective collaborative and focused efforts are required amongst the participating research institutions, professional developers, and concerned government agencies and policymakers. Thank you for watching my video, and I hope you enjoyed it. You may be able to comment what you think about it, and I'll be willing to answer.